The question number 26 is that the thermal radiation emitted by the body is proportional to T power x, where T is the absolute temperature. The value of x is exactly for a black body only. All bodies painted black and only are polished bodies. Now see, this law is T power 4 is irrespective of the color of the body. So only depend on the emissivity. So E proportional to T power 4, the formula of radiation is valid for all bodies. So answer to this question is 2. Question number 27 is a solid and hollow sphere of the same material and of same radii are heated to the same temperature. So one is solid and second is hollow, and both having the same surface area. Obviously their masses are different and both have the same surface temperature. Then both will emit equal amount of radiation per unit time in the beginning. Yes, energy emitted is proportional to surface area and the temperature. So both will emit the same amount of energy per unit time. Both will have equal temperature at an instant. No, this will be cooling at the faster rate, so this will be different. The initial rate of cooling will be same for the two sphere. And their masses are different, this will be different. Answer to this question is only the first choice. So answer is 1 to this question. Question number 28 is an anisotropic material has coefficient of linear expansion as alpha, 2 alpha and 3 by 2 alpha along x, y and z axis respectively. The coefficient of cubical expansion. If it is anisotropic, then we use the formula alpha 1 plus alpha 2 plus alpha 3, and it's given this is alpha and this is 2 alpha and this is 3 alpha by 2. So that becomes 9 alpha by 2. So the correct option is 3. Answer to this question is 3. The question number 29 is 2 gram of ice at 0 degrees centigrade is dropped into a beaker containing 10 gram of water at 20 degrees centigrade, the final temperature of the mixture. Now dear student, let's see how much energy you can get from here when this comes to 0 degrees centigrade. So mass is 10, specific heat 1 and temperature 20 minus 0. So you get 200 calorie of energy once it comes to 0. And how much energy is required to melt the ice? That is equal to 2 into 80. So it is 160 calorie. Obviously this energy is more, so the temperature will go above 0 degrees centigrade. So what happens? So heat gainer is this and heat loser is this. So 2 gram, 2 into 80. The first is the state of fusion last. Then 2 into 1 into temperature change. Let it goes to T minus 0. And the heat lost is by 10 gram water M, specific heat and temperature from 20 to T. So there's a heat gained and there's a heat loss. 160 plus 2T is equal to 200 minus 10T. So 40 is equal to 12T. Therefore T is equal to 40 by 12. And that means this is 10 by 3 degrees Celsius. And therefore the correct option is option 2. So answer is 2 to this question. The question number 30 is the triple point of water has its value of the temperature and the pressure as. Now this is just a fact-based question and you have to remember this data. This is given in NCERT also. So answer to this question is 1.